All right, hey again, Honors Chemistry. So I heard that some of us need a little bit of help with determining empirical and molecular formulas from percentages and molar mass data. So I'm going to do the other question that you need to know how to do, which is letter D, and you're going to be pop quizzed on this tomorrow. So just a quick recap of what to do when given percentages and the molar mass. So if I give you percentages of all the elements in the compound, your first step is to assume 100 grams, or what that means is take these percentages and turn them into grams. Then you want to turn those grams into moles. And then those moles you want to divide by the simplest small number mole that you get. And then whatever number you get as the ratios, that's the ratios of the elements in that compound. And then let's say you get those ratios. If I have a certain molar mass, and then I have the mass of my empirical formula that you're going to get, which is the simplest ratio, if I divide how much larger my molar mass is by my empirical formula's mass, I could see how many more of that empirical formula I'm going to need to be my molecular formula. So a quick run through of the steps that I'm about to go through. So let's do this for this last one that for this worksheet, you only need to do C and D. We did C in class. You're going to do D. So 62.1% C, 13.8% H, and 24.1% nitrogen. And the molar mass of the molecular compound, or the molecular formula, is 116 grams per mole. Okay? So now, I'm going to turn these percentages into grams. So I have 62.1 grams carbon. I have 13.8 grams hydrogen. And I have 24.1 grams nitrogen. Okay? That's my first step. My very first step is to convert all of my percentages into grams. All right, so you're going to have a test on this, and you're going to need to know that if I give you percentage of compounds, that percentage is by mass, and so I'm going to turn those percentages into masses. And then my next step is convert these grams into moles. So first step, I'm going to write it above here, is turn percentages into grams. Second step is grams into moles. And how do I go from grams to moles? I multiply by 1 mole over the molar mass, or aka divide by the molar mass. Okay, so I'm going to do that for all of these. For the 62.1 grams of carbon, I'm going to multiply by 1 mole of carbon over the molar mass of carbon, which if I use a periodic table, it is 12.011 grams of carbon. And so if I do, and I'm going to just set them all up. Same thing for hydrogen, 1 mole of hydrogen over 1.008 grams of hydrogen. And remember what the molar mass means. The molar mass means that if I have a mole of that element, or a mole of that compound, but for this one, if I have a mole of that element, the mass of that mole will be 12.011 grams. So a mole of carbon will be 12.011 grams of carbon. If I have a mole of hydrogen, the mass of 1 mole of hydrogen will be 1.008 grams of hydrogen. And then this number corresponds to how many particles there are in a mole, which you should remember that this means that I have 6.022 times 10 to the 23rd particles of carbon. That's a mole of them, and they weigh 12.011 grams. So don't forget that for your next test. Last one is nitrogen. 1 mole of nitrogen over 14.007 grams of nitrogen. And so now I'm going to do this on the calculator. So remember, I keep on repeating this. You multiply by the top, divide by the bottom. So you multiply by the numerator and divide by the denominator. So I'm going to do that just so you get in the habit of it, just in case our top number is not always 1. So 62.1 times 1, and then divided by 12.011, and I get 5.17. Sorry if you can't see that. 5.17 moles of carbon. I'll do the next thing. Hydrogen, 13.8 times 1, divided by 1.008. And I get 13.69 moles of carbon. And, moles of hydrogen. My bad. And I don't have any significant figures here, but let's just stick it to 2 decimal places. And so now I'll do the last one, 24.1 grams, 24.1 times 1 divided by 14.007, and I get 1.72 moles of nitrogen. And now I like to put these mole numbers as these fake subscripts, but remember, in the end, you're going to divide by the smallest number that we get for moles to see what is the relative ratios of these moles of elements in this compound. So I'm going to make this fake formula, 5.17, H 13.69, N 1.72. This is a fake formula, and I want to divide by the smallest number. I'm looking at these three numbers. The smallest number to me is 1.72. So I'm going to divide them all by 1.72. And if I do that, I'll do 5.17 divided by 1.72, and I get 3.005. I could round that to 3. H, I'll do 13.69. Oops, sorry, that's not right. 13.69 divided by 1.72, and I get 7.959, which I want to round that to the nearest whole number. Divide by the smallest number and then round to the nearest whole number. So relatively, that's 8. 7.95 is 8. So C3, H8, and then I don't need to do this on the calculator. 1.72 divided by 1.72 is just 1. Okay, so this would be the empirical formula. I'm going to make a note of that. This is the empirical formula. It consists of the smallest ratios possible, or the simplest ratios as possible. I can go no smaller than 3, 8, and 1. Now, get in the habit of doing this, but I'm going to get the molar mass of this. So the molar mass of this would be 3 times 12.011 plus 8 times 1.008 plus 14.007. And I get a molar mass of 58.1. Molar mass is 58.1 grams per mole. I'm rounding, I'm not using significant figures. All right, so this is my empirical formula. It's the simplest ratio. And the molar mass of my empirical formula is about 58.1. Here's the molar mass of my molecular formula. That is 116. Just by looking at this, it looks like my molecular formula's molar mass is twice as large as my empirical formula. Let's check that. 116 divided by 58.1 grams per mole, grams per mole. So 116 divided by 58.1, and I get 1.99, which is about 2, which means I need to multiply this entire empirical formula by 2. Molecular formulas are not in the simplest ratio, and they're actually made of multiple units of your empirical formula. So I could have C3H8N, C6H16N2, C9H24N3. For us, if I'm multiplying by 2, I'm going to get C6H16N2. This will be my molecular formula. Okay, so please watch or rewatch this video, follow all of these steps, or at the very least copy this for your notes to answer, because you are going to get a pop quiz on how to do percent composition, and then using percent composition to figure out the molar mass of a compound or the empirical formula of a compound. Alright, so I hope this video was very helpful, or both videos that I just posted were very helpful. Let me know if you still have any other questions, comments, or concerns.